All right, and we are back. Hello and welcome. Everybody who saw the first couple seasons, welcome to our third season. Thank you for joining us on Code Live with Google Cloud. Uh, this season, our subject is GenAI with 2 million tokens, and we are extremely excited to have you. We are going to have a variety of guests this season to show us all sorts of things around what 2 million tokens really means when it comes to Gemini's context window. So, some folks will be live coding with us. Some of us will be talking about the concepts. All of the content will be to get familiar with what 2 million tokens means and what it really feels like. And to that effect, we've brought on Jason Davenport, my colleague, to take us through a very interesting subject today. So, Jason, why don't you tell us what we'll be talking about today?
Yeah, thanks, Aaron, and thanks all for the folks who are tuning in today. One of the things as we think about kind of the model ecosystem and all these things is, well, how do I actually leverage, 1 million, 2 million tokens, and then what are all the cool things that we can actually do in order to, keep our costs down, optimize those things of it, right? Because if you think about it, in 2 million tokens, sometimes it's scary from the perspective of, oh, if I'm running that every time, like, what is this going to like run me as the developer, and then my organization as a result of that. So what we're going to go through today is really more of like what I'll call kind of the API mechanics, not focusing so much on the prompt engineering or those sorts of things, but what happens in certain things, how do I think about, things I could do, ahead of an actual LLM call, during and after, to then make some cool things happen.
Absolutely. Rich subject, all kinds of considerations in terms of like response times, I assume, definitely cost. So, yeah, I feel like there's a whole lot of ground to cover. Let's get started.
All right, let me pull up here and let me get a window shared. And I think I'm sharing. Can maybe? Oh wait,
We'll just
hold
add that.
on. There we
And
go. Look at
by the
that.
way, as we go, feel free to ask questions in the chat. We'll be taking breaks every so often whenever something comes up to just discuss it because we're learning alongside with you.
Cool. Um, yes, absolutely. For folks, if you have questions, please put them in there, and I'll read through them. If I can't answer it, I'll obviously let you know also. But let's keep it, as interactive as we can on the internet for these fun things on it. Um, All right, so what are we going to use really to start talking about this stuff today? Where I'm at, if you're looking at my display, is I'm here in the Vertex AI Prompt Studio. So think of this as, if you're moving from AI Studio into Google Cloud, this is really kind of our rough equivalent of working in AI Studio for it. So probably a lot of folks have seen this here. But we're going to use this as kind of our starting ground for then talking about some of the other things that may be happening from a model and all that fun stuff perspective. So first thing that you'll notice, so one of the things that we kind of think about is, how do we cross these boundaries of different things and what happens as a result of that? And you can see here that I have a video that I've recorded. It's just an internal demo video. Everything's fine in it. We can see here that, in terms of the token count, that this video is about 1.45 million tokens. This was about a 90-minute session that I did here the other week. And here we could do something, just using this video to ask a prompt about this and the product for it.
Okay, so
So
for reference here,
yeah,
that video is 90 minutes. Is it a screencast? Is it like a 1080p kind of recording of your screen?
it is. It's a Google Meet recording, so 1080p, some different video aspects, some product that's displayed on a screen share, and that's actually talking about our open model Gemma for most of the time, which is pretty cool, and then some other framework pieces that we have, which one of them is Mesop. If you haven't seen it before, kind of a cool Python to application as code type thing for it.
Very cool.
So first thing, if you notice here in Vertex, so there are some model differences that I'll call out for those who are following along. Right now, Gemini 1.5 Flash in Vertex is a 1 million token context window, where I believe in AI Studio it's 2 million. Typically, our models, when you think about moving from AI Studio into Vertex, have a little bit of a lag just because we have a number of large customers that are using the models here in Vertex. So sometimes there's a couple of additional things that we might do in terms of testing and hardening as a result of that. But let's go ahead and start with the Pro one, and this is going to take a couple of minutes, so I'll kick it off. But keep in mind, right, if you think of some of the differences, which I think folks are probably right about, differences between Pro and Flash. Pro is really focused on reasoning, so tends to take a little bit longer, right? But thinking through, okay, what are the things that need to happen? What's the reasoning between getting from point A to point B, and then what's the response for it? Flash is highly cost and response time optimized, which is great. But we do that right with some level of performance trade-off. Although if you look at some of the new stats on LMSys, in particular for the models, the experimental models that we dropped yesterday, like they still perform really well, all things considered.
That is absolutely fair. And I'd heard a lot about the response time optimization. I hadn't actually heard about the reasoning optimization before, but I have been using Flash a lot, and I've seen the response time difference firsthand because I was using it in blog posts a couple months ago. We just used it live yesterday in a live stream, actually. So
yeah. And so, I don't know if this one is going to have it in there. Oh, here you go. So you can see some of our recent stuff. So just for reference, I'm on Hugging Face. Hugging Face maintains a great leaderboard. Right now, absolutely. If you look at some of the arena score pieces, some of this is obviously voting and other things, but 4 is a great model. 1.5 Pro experimental, which is the most recent one we've released, is also doing well. And then we can see also the most recent 1.5 Flash release is also performing pretty well on this. So, cool to see, right? These are things that we're continuing to just try to bring back to the developer community in it.
Absolutely. Okay.
So here you can see. I asked a simple question. The goal here is that we talk a lot of Gemini in this video. I could play the whole thing, but it's kind of ancillary to this. We also have a couple of things that we could do, right, in terms of changing our temperature. So obviously a lower temperature is going to be more deterministic, although it is still non-deterministic, even if you set it to 0. 2, obviously, in Gemini is going to be what I'll kind of quote a more creative response.
Okay.
But what we see here, so 1.5 Pro, obviously is a 2 million token model, so we were able to get 2 million tokens in. Let's try now with one other thing, and I'll kick this off. So I changed my model type to 1.5 Flash. I'm going to go ahead and kick this off here. But let's see what happens, right? Because this is a 1 million token input window. It's not a 2 million token input window. So what's going to happen? Let's go ahead and find out.
Right. What happens when you're 50% over? I've never, I don't think I've seen any writing about this. Maybe I'm just not reading deeply enough about AI models, but yeah. And our response time was about 1 minute for the last one.
It was anywhere from like a minute to 2 minutes, which, when you factor in kind of the length of pieces here that we're talking about, and going through these things, like relatively decent, 2 million tokens, right? Like that's a lot of information that you're passing and crunching.
It seems like this input specifically seems pretty comparable to like a feature length movie. Okay.
Yeah, cool. So here, so we've got something, right? So let's talk about things that happen here, and then how we can start getting around it, because that's the fun part, right? That we get to do as developers, is what happens when something like this thing goes wrong. Mm-hmm. So first thing here, you can see what my guess is, just using the studios, that we probably hit something around that context window. Not particularly a helpful error message. So, let's start to actually, do this from kind of a code interface, and then see, what's the things that are coming up in it.
Absolutely. That's fair. So I guess you'd receive a similar error response from Vertex SDKs as we're seeing here if you had sent this over.
I'm hoping so. But let's see.
Yeah.
So what I did, so like AI Studio, if you've used that before, One of the cool things here, if you come up, you hit Git code. Here we have obviously a number of different examples. We have Python, Node, Java, and then just straight HTTP requests. I went ahead and just hit Open Notebook, which essentially takes this code and then packages it into a notebook-like interface here. And I could do a couple things. I could do essentially the pip install, or we may be allocating runtimes. I actually have this locally, so we're going to shift over to that because this is going to go a little bit faster. We can see here that I have that library, and then I can actually open a new notebook.
Actually, Jason, we're not seeing your screen here.
Oh,
but what we are seeing is your safety settings, which I've never actually played with the safety settings for I know that they're there and they're editable in the AI Studio, but yeah, I've never actually passed them in myself with a request. So I guess I will
here. Yeah. Well, let's touch on that one here in a second. I fixed my screen editing things. This should be popping up shortly.
Perfect.
There we go. All right, now I'm sharing my full desktop because I'm still a Google Meet challenge sometimes in that.
Fair enough.
Cool. So we have these different things here. I obviously have my project. I have a few different aspects. I'm going to use my Python environment and connect to that.
Maybe we could zoom in a couple times.
Yeah.
It's absolutely.
And we'll
seems like a straightforward
We'll trash the side thing. We'll get rid of that. All right. So now we're going. So here, essentially what you can kind of see is what we're starting off with from a safety perspective. Think of this as kind of a check on the output that the model is going to give us. We're essentially checking for a few different types of categories of material. So, hate speech being one of them, dangerous content, explicit content, and then content that we may be deemed as harassment. Blocking here, so there's a couple different thresholds you could set. In the UI, you'd see a kind of a slider, right? You'd have none, low, medium, high, right?
Right.
And depending on what you set it right, sometimes things will get classified, in one of these settings, and maybe you didn't mean for it to be. So know that sometimes if you don't get a response back, maybe you have something here where in the response it actually says, well, there was some sort of thing that was identified, right, to be dangerous content as example. And we can show that here if we get a payload back or just use an even small one for it to see that difference.
Very interesting.
Cool. So good, right? We actually still got an invalid argument error. In this case, we know that this is 1.5 or 1.45 million tokens. So we'll probably have to do some things to actually parse these things out.
I guess my first, do you mean parse the error message out or parse the
parse the file?
Yeah, fair. Yeah. I guess my first thought is if it's a video file, I could lower the frame rate, reduce the resolution. I guess I'm not sure how I'd actually go about that. Off the top of my head in Python, so I guess I'm gonna learn something too.
Yeah, so there's a couple things that we could do. I have this posted on cloud storage. So one of the things we could actually do, and this is what we're starting to see as a more common pattern, is actually thinking about how do we route to different models. And so I think for this one, what we'll probably go down is thinking about, okay, how do I know what's the size of content that I would use? And then how would I actually pick the model for it, right? Because we know that one of them accepts 2 million tokens. We know that one of them only accepts 1 million.
Right.
But to your point, when we start to get into things like changing the original content.
We're talking about live transcoding as a part of my API request. If a customer is waiting for that request, you're right. It's probably a better idea to route to a different model that'll be able to fulfill it as is.
Yeah, and what gets with that would also you start to run the risk of is if you're searching for specific things about something, at 1080p you probably have high enough resolution, even on my desktop with this, to say, okay, is there something on the screen that needs to be detected? Think about if you go down to 480p or something like that, you're losing actually a lot of fidelity in the video itself.
Right. And
so, depending on the question that you're asking, that may be okay, but may also like be like very, very wrong in that flow. So typically, if we can just route to something that can manage, the similar requests, maybe it costs a little bit more for one or two times to do it, but probably is still, incrementally less expensive than you and me, messing around with like trying to transcode a video properly over the course of, 75 minutes here.
Yeah. And it likely is, in terms of fidelity and your server's actually returning useful responses, it's probably cheaper, in fact, for the customer to send 2 requests or to get 1 request properly than to get 2 requests and not have the right answer returned.
Yeah, exactly. Cool. So let's start actually getting into some of the API stuff, right? So first thing that just for reference, I'm here on the generative AI for Vertex AI documentation. One of the things that I actually want to do is think about, from the first perspective, because we ran into this there, okay, like how many tokens are actually in, some sort of payload that I'm using, right?
Mm-hmm.
And so we actually have a pretty cool thing here, which, is aptly named the Count Tokens API. And, keep in mind, right, when you think about tokens and that sort of stuff, really what we're thinking about is, kind of like a representation of letters, right? So we tend to, tokens are usually kind of words-ish. When you think about it, roughly every tokenizer is different. I've come to learn, but in kind of our world, in the OpenAI world, I hear 4 characters per token is roughly equivalent.
Fair enough.
Now for video, right, like there's frames and other stuff too that go with that.
Yeah, I guess like the presence of this API kind of suggests it is not a trivial calculation. So yeah, I definitely, I wonder how much it would vary, and as part of routing different models, how many different tokenizers I would have to calculate between. But I guess a rough estimate would get you pretty close anyways.
Yeah, a lot of, I'd have to go look at some of our other folks out there. For us, for reference, calling the Count Token API is always a free call.
That makes sense.
So, think of this as like just like good due diligence that I may want to do before I actually go and do the thing for it. So here you'll come in, I'll do my very special project. I have my region. One of the things that we're also doing, we have our model here. So let's look at some of these things that are coming through, because tokens are obviously very important.
Absolutely.
All right. So just ran this. This is a very simple call. We'll come back to our video piece here in a couple minutes. A couple of things there, right? So you think of the prompt. So why is the sky blue? First thing, as we pass this essentially into the actual token count, here you can see we have 6 tokens. So why is the sky blue? There's probably some level of tokenization with each of the words, and these are pretty short words as a part of that. The fact that there's a question mark is probably also a token, just because there's some implied thing that kind of comes through with meaning as a part of those things for it.
Right.
The other thing we give you back is essentially how many billable characters is this going to actually use for input. So if you were to go say all of our pricing is actually by characters, not tokens, right? Well, how much is this call going to cost me? I could go calculate this based on a pricing sheet. There we go. You can tell I look at this stuff a lot, right? Because it's like a top 5 result. Here you can see essentially what we're passing in. In this case, it's text input. So it's roughly what is that in Flash? It is
one 10,000th of a cent,
something like that. Yeah. A cents one. Yeah. So 100,000. Yeah.
Yeah, I
think it's 1/1000th or like 1.81 like thousandths of a cent or something like that. Probably not material for this, right? But as you think about all the things that are coming through, what's up, Riff? I haven't talked to you in a while. I hope you're doing well. I'll get to your questions here in a couple minutes. Think about like these things, like when you start to do like hundreds of thousands of these calls or like agent-based calls for it, where there's a lot of model chatter, this actually can become material, right? But for doing things like testing, validating that your use case actually works properly, and these things like these models and these things are actually really powerful for like proving, is generative AI useful in my use case for it.
Absolutely.
Cool. So
Do you want
let
to
me
take
see.
some
Yeah,
audience
yeah.
questions to start here? All right. So we
Yeah,
have
Riff, go ahead and read it out loud and
Rick
I'll,
Piano. Yeah. The question is totally okay. You want to use Gemini's large context window to enable managers in your business to ask questions about the code or data model within our source code. And then part two, you have, are there best practices for effectively loading the source code into context window, like drawing into a source tree? Two good questions.
yeah, so let me, here. One of my peers just wrote an article about doing some things in long context windows with code, and let me see if it is on Medium yet where I can share it out.
Absolutely. And hello Samu. Kaio Mark is not on the stream, but he'll be back, I believe, next week. So definitely stay tuned. I'm also, as we're looking at this,
Oh, go ahead.
yeah, as we're looking at this pricing screen, not to distract from Riff's question too much, but the use of a second as a billing metric raises all sorts of questions. So maybe we can talk about that next.
Yep. Yeah, we'll get to that here when we get past the video thing. Riff, there should be a post from Carl on the Medium Google Cloud blog. I will find it and send it to you after this. One of the things that we think about, though, and just like conceptually, when we think about the long context window, generally for code, we kind of use like a parser and concatenator to load things in. I was actually working with one of my other colleagues on doing this with notebooks, and so he was using there's like a Jupyter to text type utility, or like Jupyter to Markdown. I forget what specifically it did, but what was cool is it would take it, like make it like kind of like a novel that you could pass into the LLM, but it had different like code annotations and things in it, so the LLM could still understand. Here's what different blocks represent, and then he's using it for generation to say, hey, here's 4 notebooks. If I wanted to do something else, like use these 4 notebooks as input and make me a new notebook as a result of it. So I'd say start with kind of the, hey, can I just load in like all of the context pieces and kind of a big thing, and then pass it in. I've also anecdotally heard using things like YAML and XML syntax ironically worked really well. XML syntax, for whatever reason in particular, I thought I escaped XML 5 or 10 years ago, but apparently it's coming back.
Absolutely.
But that makes
for Java.
I know, right? But those can help too. You can start to get into more interesting things when you think about graph. So, we just announced some stuff with Cloud Spanner where you can essentially, based on tables, actually create graphs on that. You can maybe look at something like that depending on your search quality and results. Hey, I know that A goes with B, kind of like an entity, like an ERD diagram. So in database terms, that's just a diagram that has all the different parts and connectors. But I probably concatenate the code just to start and then see what comes in. And then obviously in the thing that we're talking about in particular, things like data models, and that is like your metadata input quality. Yeah, I would actually look at, if you don't have good stuff, like using an LLM to generate some of those things for it as well. I hope that answers some of your questions, Riff. I know there's probably a lot to unpack in some of those different things.
Yeah, I feel like there's a lot to explore. I've had, just anecdotally for myself, I've had great luck. Gemini has surprised me, and other models of you has surprised me by just kind of understanding what I lay out in plain text surprisingly well. Even when I'm asking it to understand like large kind of bits of creative writing or multiple files across multiple languages, just labeling it as, this is my README, this is my front end, this is my back end, has been pretty coherent in my experience. So hope it goes well for you, Riff. Now we talked about.
All right, so we started talking about some of the fun things we can do with the API, right? So we went through. Let's cover a few different things with tokens, because we were doing that. All right, so we talked here, when we think about essentially the count tokens API, this is really helping us with what I call our input tokens. So, how many tokens are we going to give to the model in order to get a result? But there's actually a number of things then when we think about the output from the model that are somewhat controllable as well. And so if you come back to our friendly table, we see here that we have both the inputs here, and then we have the outputs. So, essentially like what we're getting metered on is how much comes out of the model for it. We can't obviously know the number of tokens that the LLM is going to have ahead of time, because it's by nature kind of a non-deterministic. I'm going to ask it a big question, and I may get widely varying results depending on what I'm trying to do for it.
Right.
So here what we can see, first thing, when we actually look at the metadata, in this case I've called my model here and I've had the prompt. The metadata contains a few different things which are interesting for us to look at. So the first one is essentially the prompt token count. So great, this matches. But what's actually interesting here, if you think about then the output, so our output is actually not necessarily only the text that's displayed. There's actually the concept of candidates as well. So
right.
Candidates are kind of like, what are all the options of response that the LLM has provided to you? And, kind of cool then to think about, right? Because we could also, let's say we just wanted to print the full response.
Yeah, I think I've seen it listed as predictions in some APIs as well.
Yep.
Where you have like confidence scores associated with which one you want to hear.
Yeah, exactly. And so you can see here I have my content. I obviously have the parts of that, but then I would have some sort of potential candidates for that if I had multiple candidates. And so there may be cases where I'm actually getting many tokens they're being used in output, even though I may see fewer. So just something to think about as you start to think through some of these other things is what are things like candidates and all those things with it. And we actually have we now have a way as of I think this is the AI platform 1.64 in Python as of 1.63, and with the API calls and other libraries as well, you can actually determine the number of candidates that you want to return, which is kind of cool. And I actually had that pulled up because I was messing around with this earlier today.
Absolutely. That is fascinating. I guess I would never have thought of having the idea of leaving headroom for the size of the predictions for my response. But
yeah, let me here we go. I think, is this the one? Generation config. Yeah, so if you look, I'm just on the Python SDK, but this is obvious. This I believe should also be available in the other ones. One of the big ones here is candidate count. So candidate count in this case essentially will go through, and then how many do I want? Do I just want the first response that the model gives me? Do I want the first 4? Do I want the first 8 in that? It starts to give you a lot of options, right? When you're thinking about what's the best thing to actually return.
Do you know in terms of response time whether the parameters like candidate count and max output tokens would have a significant impact on how quickly it'll process a large payload?
So processing time, maybe not. One of the first things that we typically think about as we go through some of these things is one of the most common metrics is time to first token.
Okay.
So think of that as, let's say I'm in a chat application, because that's one of the easiest kind of ways to think about this. What happens, user types a question, how fast are they going to start seeing the response, streaming back to the user? So if you're using the stream method, right, where as the response is being written, we're sending it back to the user in that, that will usually minimize your time to first token metric for it. Getting the max output, depending on the model, right? Obviously, the more characters that are going to be returned, the longer it will take, right? Because we're talking about, bits and bytes to like go over the internet.
Fair enough.
But in this case, what we're really doing with max output is typically saying like stop at a certain number.
Right.
So stop at 256. Stop at 4096. I'm just using kind of like the bytes, numbers for it. But those are things that go with it.
Absolutely.
While I'm here, so one of the other new things which we now have in the API, which I am actually pretty excited about, is the ability to set a seed value. And so for those who've worked, with some other large language models out there, typically if you're using a seed value, that allows you to get more deterministic in terms of the output result that you get. So we could obviously dial down the temperature, which will kind of air quote reduce creativity of the model. We could also set a seed value, so that way the input is always going to be a similar thing for it. And I just call it, it helps with determinism. It does not, though, actually make a LLM deterministic in it. So
Absolutely
just
fair.
be aware of the two differences there.
But I might use this in a scenario where it's more of a sensitive use case, and I want to be sure that it's close to what I'm giving it direction for.
Yeah, exactly. And we could, let's pull it up here. I have my model. Need my generation config. I just forget the order that these things actually go together in it, so we'll play along with it. All right, so we have our model, and then I believe here we do. Here. All right, I put in my Python thing. What I'm going to do is I'm going to say, let's start with just temperature. And I'll make sure this runs.
Fair enough. And so we'll set that. So this is the minimum value. And I see that there's enums published for, the harm categories. Are there similar enums for all of the parameters? I'm guessing temperature, probably not. It's a float, but.
Yeah, so you can, depending on what you're looking to do, there's obviously, like if I come into the generative models piece here, there's those categories. There's like how I set different pieces of content, so that's obviously a big piece of it. How I can go through and set different categories, those sorts of things matter. If I come over, let's use, if we're talking on, safety, right? Here. Have an example pulled up. So it's probably generative models dot is what I'm looking to actually set with it. But you can see here, so we're importing these different things. We can see we have a safety setting here in terms of our config, and then we're actually using it as generate content. So that's where I needed to put it as a part of my piece in it. Let's go ahead and make the changes. Oh, here we go. That was silly of me. And I have it right here.
Yeah.
You talk so fast that you don't look at the screen, and that's the result that happens with it. So let's go ahead and add these things in. So we'll go ahead and add a seed.
Perfect.
Maybe we'll do. I'll just pick a number.
And so the seed value is it a float as well? Is it just a?
It's I believe it is an int.
The int. Okay.
Generation config. Yep, it's an integer value that you pass through on that. And so we could do that. We could also say, let's do, I believe it's candidates. We'll do 3. Oh, I put this up on this one. Let's move it down to this one. Here we go.
Yeah, fair enough. We'll work back up. We'll work back up to our video response.
Yep. So I'll do my config. do my seed and candidates. They'll do this. They'll do that. I do a lot of copy pasting from these things, if you haven't noticed.
Absolutely fair. Coding's not a typing test. I've wasted way too much time being one character off.
That is like the story of my life. Cool. So you can see here, right, when we start to think about, seed is obviously going to be driving some of our determinism, but I could also, change essentially my candidates. So we can see here, I've set 3. Let's see what happens if I just set it to 1. So you can see that because these things are actually going back and forth, we can see here that we're getting a few different counts.
Mm-hmm.
So these are just things where it's like, as we think about, what are the different things that we can use to tweak our LLM, some of these do, actually, change, what the different outputs are of those processes. So, pretty cool, right? Like when you start thinking about, okay, like what are all the, ways that I can, not fine tune, right, but like tune the output. And
Right.
then really think about, okay, are you using something like deep eval or like GenAI eval service, which is something I think we call it rapid eval in our docs. Things that we could do then to say, okay, are these responses actually what we're expecting to get as a part of our model and all the fun stuff for it.
And it's not a step that I've seen covered very widely. Like I've largely just messed around with this and kind of seen what values feel comfortable for me when I'm at the testing development stage. So it is. It's not obvious, but it is interesting to see live.
There's a lot of cool things you can think about when it's like, okay, how do I have a framework for then doing my testing? So, hey, I set a few values. I kind of have maybe a ground truth, I know is the right one, and maybe it's actually even a handwritten ground truth.
Right.
You set that, and then you're using rouge or blue, which are kind of 2 metrics on evaluating groundedness of an answer. Do you have a the equivalent of hyper parameter tuning to then play with the different weights to see how close you get? It is still one of those things also where it's you can overfit to something, right? And so how do you avoid that?
Absolutely. No, it is interesting. I've never thought about how every time I understand one more of these parameters, these levers to play with as I'm tuning, not a model in general, but a model for my use case. I'm always thinking about how will this apply to the next one, and with the video specifically, I'm so curious about how things like playback speed and frame rate will affect the quality of responses. Not to change subject too much, but once we get there, I have all sorts of questions about because it would increase the playback speed be the equivalent of reducing the resolution for a video request?
I think you can do some of that. I believe there's, with a lot of these things, there's typically hey, we process a frame a second, or some there's some attribute of that. You could always look at doing things so frame dropping, right? Depending on what the use case actually is that you're trying to do. A lot of video stuff as example, what are you at? How many videos do you need? If I'm, walking down a retail shelf as example, and looking at out of stock, segments, right? Do I actually need, a continuous movie of me walking down the aisle, or do I need, the equivalent of 50 frames of information as a part of that instead?
Absolutely.
It's what's the business case around it? If it is a speed use case, then maybe that's something else. I've seen a demo. We did one at Next using mini golf and using OpenCV to track. Right. I've seen other ones with generative AI where you're tracking actually the movement over a series of frames or something like that. Maybe you do need all of the frames then for that use case.
That's fair. It's kind of like using a high speed camera versus needing the occasional screenshot for security camera.
Do you need the audio?
Yeah.
Sometimes the audio is highly useful because what's on the screen isn't actually the whole story.
Yeah. And jumping back to the config, the generative config that we have. So when you're setting a seed, we are just thinking of it as an arbitrary int to like draw a line in the sand for how the model is generating its response.
Yeah, so you can see, we'll come over, 404, how did that happen? So one of the things here I was going to try to find a better thing that kind of describes like what the seed does, but it's essentially one of those ways that we can, tune to something and say, hey, like start at this point. And then based on, what we're going to start with, do something with it. It's like this, it's the seeding parameter. So here's we won't go fully into the thing, but here you can see like what I'm doing is essentially saying like when I ask for something, I send both the prompt and the seed with it.
Mm-hmm.
And so in a lot of cases, this could be random otherwise because it's an integer, right? But what we're doing is essentially like trying to give it as many input, things as we can in order to get what we ideally want out of it in the process.
That's absolutely fair. So if you were trying to fit it to a specific use case, I guess you would just kind of run a variety of seeds and prompts through like your own benchmarking, your own use case, and see which ones come closest. And then if you need to lock the determinism down, you would offer that specific seed with your low temperature, and that's about as close as you can get.
Yeah, and there, now we're sorry, and we probably won't cover all of these things, right? Talking about like when you actually fine tune. What you mentioned, like problems around like classification, are actually like what we see in many cases, like a good like fine tuning problem if you need to go down that path. So fine tuning for a specific thing with like some typically like human evaluated like scoring, hey, this meant this, this meant this, this meant this.
Right.
And then we would pass that in and let the model kind of tune what its weights are in terms of the desired output for it. There's a lot on fine tuning. Typically what I tend to say is like start with like prompt engineering and like the context windows stuff before going to fine tuning, unless like there's really a use case that you have that warrants it. Because fine tuning, you're then into the world of kind of all of your own model management as well. Which is a lot, right? You're managing the infrastructure, you're managing the serving architectures, you're managing what the actual model is, right? Which is the one fun thing that we want to talk about. But it's a lot to handle.
Absolutely fair, and I'm a big fan of if you can pass a responsibility further up the stack, absolutely do it. If you don't have any meaningful decisions to be made about how your app is built, use a build pack, etc. So I feel like the same principle applies, where you want the principle of least responsibility when architecting your AI app, AI service.
Exactly. Cool. So let's say here we have so let's come back to thinking about, okay, how would we actually like build kind of this like multi-agent thing, right? For instance, we have, what we actually want to do is we want to go through and we want to give our parts. And here, what we're going to do is essentially do this video piece.
Right.
And here you can see that I'm just, we're going to do a quick curl.
Yep, just structure a regular multi-part file.
Yep. Yeah, exactly. I'm just going to paste this in because I don't want to have to work out of 10 million tabs.
Absolutely fair.
Here that what I want to do, so I don't want to use 1.0 version, I'll use 1.5 Flash. I want to do my thing. And then what I typically always do in these things is I'll run this and then make sure that I can get the sample to work before we go and like mess with anything else.
Totally fair. Good way to go about getting an MVP off the ground in any case.
It has varying degrees of success, but I would like to think that it works for me from time to time. Cool. So we got those in there. Now let's do a thing, right?
And
let's see if my curl is for. Oh, there we go. Look at that.
There we go. All right. So we have 16,000 total tokens coming back. We only, I guess, billable characters aren't. It's really just the metadata, I guess, with the file name that would be parsed.
Yeah, so there's a couple things that typically come with like the billable characters part of this. So taking the image part aside from there, what we're looking at is what's this metadata, and then what's the actual prompt text that we passed in.
Right.
So here you can see that we have. Where is it? So here we have text. So we have text, which is provide a summary about 2 sentences for the following article. So we have our, essentially characters that we're inputting as a part of that. And then if we come back, this is where it's always good to have some of our metadata available about what we're going to do that work on. So we can see here, if we needed to go grab the metadata about that file, it would be roughly 2 cents a second then for that to essentially be used.
That makes sense. And I suppose like every time we were to cache a request, we'd be saving 2 cents a second if we can manage to actually return the same response.
Yeah, so caching is pretty cool. Caching essentially, and we can show that here in a second. What it allows us to do, so the minimum input is 32,000 tokens. So that's a good thing just to call out when we get to it. And we'll try it here with like 16 just to see what happens, right? Because one of the things we want to do is design around the failures that happen, obviously, for this stuff.
Right.
Then what happens if folks here have worked with like a memory store, Redis or something else, once we've loaded it, now we're just paying for that to essentially like sit in memory for a period of time. And so with context caching, let's pull it up. Cache frequently used content. Cool. Essentially what we're going to do is we can pass in a number of different attributes. And then what we're metered on is, essentially how much goes through that first time, but then how long we're actually holding it in the cache. So, hey, if it's I'll make up a contrived example, a 15-minute user session. We probably then want to say a cache has a 15-minute TTL or time to live.
Right.
And then, we're going to expire that at the end of it. The other thing that I'll call out here, and I believe this is here in the update, so you can see a couple things. When we think about the update, really here what we're talking about is like updating that TTL or the expiration time of that cache. But the cache is essentially, once we load it up, I believe the developer terminology is like it's immutable at that point.
Yeah.
And that like you can't like add incremental things to that window. You would need to essentially replace the cache with a new cache if you get into it.
That makes sense. And so you would be able to you would write your desired TTL as you're writing to the cache, and I assume could vacate at any point. You could clear any entry in there. Yeah.
Yeah. So this is really like what I kind of like about these things, even though some of the terminology is different, right? So like we're just back to like application development principles.
Yeah.
Hey, like how long do I let user data sit in Redis before I expire it out? What information do I want to do that with? Cache, like this caching method is really useful when you think about like RAG in a long context window. So retrieval augmented generation, like how am I giving additional information to the model to reason and make answers with it. And it's nice if you think about like take our 1.5 million token video. Here I'm just going to load it once, and I could use it as a part of that context, and so I don't have to reload every single time. And then I'm only paying for the essentially new questions and output as a result of that. So
that is fair. Very interesting. I feel like I'm seeing all kinds of use cases that could be tied to, you could have the end of a user session kick off a job that would expire in another 24 hours, 15 minutes, depending on how likely you are to have the user come back and reuse this content. Very, very interesting.
Yeah, it's kind of cool, when you start to think about like how are you like giving reasoning things like to an LLM in the process, and like what do you actually need for reasoning? like take like a website with recommendations. I think some of the most interesting like applications of LLMs are kind of the things that we don't see.
Right.
Chat is a very intentional, like turn-based interface. So, in like the old school days, we would call it like you're giving an intent. So the intent's like your message. I learned that, and I was very confused for a long period of time, like why it was called an intent, but that's what it's called.
Yeah.
Um, and then like you're getting a response back. Well, I'm also providing intent if I'm like clicking around on a website. So, how based on the click, like could we use, that click with context in order to like provide something else to me as the end user for, recommendations or something else for it? I think that's where things, start to get really interesting as you think about, different use cases and applications. You could even provide like 5 examples and then, maybe even do like more automation or like tool calling, as a result of those things, which is pretty cool.
Absolutely. Yeah. And to your earlier point, like you can get a lot out of prompt engineering, especially in these use cases where it's more invisible reasoning. You can ask Vision enabled API to interpret a message, interpret a picture, turn it into text, and then use that to key off of a like retrieval use case, and you can get a lot of signal out of that little bit of prompt engineering.
Yeah, exactly. So let's look at our video, right? So we got our things in here. We'll look at my notoriously like terrible dev environment that I'm using for this. We have our curl here. We could change this for the sake of example. Like I could just say like, what's in the video, and I'll make sure to export this so it's refreshed, and I'll run a quick curl. Cool. So now we can actually see, right? We're back to 1.45 million tokens.
Mm-hmm.
Pretty good, right? Like,
absolutely,
we could do things with it.
And that was a quick response. So sorry, we just queried. Were we asking it? Were we just hitting the get tokens API?
Yeah. So we just queried and said like, how much is actually in this? And you can see, right, it was pretty fast. So as we think about the actual like the wall. Like your wall time in terms of a call, like this is pretty like minimal in terms of your total like LLM wall time to like figuring something out, which is great.
Absolutely worth it as a intermediate step to like determine routing and see if you need to call Flash versus Pro. Good to know.
Yeah, so so let's say we had some of these different things, right? And I wanted to mock this flow up and maybe do something with it. Let's say I come up to our original code here. So we have one generate here, which we could then start to modify. I could say maybe I want to pass in 1.0 Pro. For this one, what I will do, and just to like kind of show this up, is I would say. Maybe my first step is, okay, like I have a new piece of content. I want to get the total token count of the content and the prompt. Makes sense, right? Python, or sorry, SQL notation kills me every time. And then, so what I might say here is, okay, like if less than some like model max, use model A, and then essentially the else on that would be else use model B, and then I would probably do something like the last piece here, and we could probably mock some of this up if you want, but we'd say like also write out what happened to some table, so I could actually say, okay, like what used the more expensive model, and are there things that I should be doing around this to make something happen. There's a cool article that was published relatively recently, uses a very similar router flow, but talking about like question complexity. So having, in this case, we're using a token count. But you could imagine this actually being like another like LLM call, like or even like a small language model call where we might say, hey, classify, the intent of the question. And then based on, that, then apply some, router framework to actually, going to different LLMs, or using the same LLM, but like very different prompt templates to ask the question for it, which is pretty cool.
That is very cool. And you could get very robust here. You could have it, you could have it request the max from each of the models, and then
Yeah.
log which one was, at least as an info log which one was used, write that along with the cache as metadata with cache entry. I think there's a lot you could do to make this much more robust than just a simple question and answer.
Yeah, and you hit on a few like pretty cool things in that, right? It's like, how do we like really bring these things to life? Like how do we use like the prompt templates to say, hey, like, model A is not actually model A, it's like template A with model A, and maybe this other one is template B
with model A. Yeah.
With model A, and I may choose to our discussion, we can share a little bit more with caching here in a second, but maybe like, and I'm just going to do 1A because I don't want to go renumber everything.
Yeah.
But here, once we get that token count, maybe what we're going to do is we're going to actually cache our artifacts first with the TTL.
Yes. Yeah, that could save us a lot of just like sending files over the wire over and over again.
Yeah.
And storage. Yeah.
Yeah, and it's just, it's like some of these things, it's like how many things do we have to manage like when we're doing something. So if we cache this, what we're essentially going to cache, if I come here, just because this is I think one of these has a nice way to show it. Maybe not. What we're caching with this is essentially like our system instructions and then the content. So what's nice about that, and I apologize, I don't have a better view of that, but essentially we're saying like, hey, the system context or instructions are really things like you are an expert coder, right? And we're giving it kind of like a role play, something to do with that. We cache them the content, like the actual content with that, and then all that we're doing with the context cache is we're just appending our questions then at the end to it. So it's a pretty straightforward method, right, of using these things together. But it's super cool because then like let's say I have this in there. Well, it's like I'm just asking like incremental questions and like getting my responses back probably will save me money. But what's cool is like I could also meter this and say, well, hey, based on like media size or something else, like do I actually want a context cache, or am I okay rolling with it? Just pay go per call with it. So because we have that token, like the token count API, right? There's actually a ton of things that we can do as a result of that with just some like pretty basic logic.
Yeah, I'm always impressed by how much of my complexity I can shift over to just proper context or proper prompt engineering and off prompt. Like, yeah, you are a fashion designer. Give me an expert response. Give me an analysis of what this image is. So very interesting. You could even save cache space here. And
yeah, and what it is actually, I just saw a comment from chat. Like, it is actually pretty straightforward, right? Like, this isn't things like I had to go read like research papers. It's like call a couple APIs, and it's like I can use all these benefits of an LLM. So it's pretty nice from those perspectives. You could even think, one of the things I think, and this is like, I call this like Davenport's terrible ideas category, of which Aaron is well versed and has seen these happen before. You think about like the output window, some of these, so most outputs are, around like 8,000 tokens of essentially output, or 8,000 characters. I can't remember which one it is offhand. Maybe with context caching and then like using like additional like prompt context, you could actually provide like the output as like more input, to the model, and then kind of have this like recursion that happens. If you have things for like, like data set generation as example, like don't create the same like synthetic data over and over. like use recursion and like put the generated output back and then make another model call and generate it back to like do some of these different things with it.
Interesting. Yeah, you did talk about having like another model kind of supervise or classify your input. The idea of having a model kind of supervise itself is also very interesting. I feel like, and you may even get more use out of caching in that use case, because the responses that you're asking to that supervising model may be more similar than typical requests to that model.
Yeah, and you hit on something that I also think is super cool, and like probably won't cover it here, but like multi LLM agents.
Yeah.
So like one of the first like ones that I came upon, and like I liked it because it explained things in a way that was very like easy for me to grasp, was like the agency swarm model. If we went onto GitHub, it's just an open source way of thinking about agents in it.
Okay, I'm not familiar.
I don't know that it's the only reliable framework, but it is one of the frameworks. But they have like different roles that you can essentially have as a part of their agents. So you have like the CEO, you have a developer, you have these other kind of like things that allow the LLM to role play. And what for me, like one of the things that was hard for me to like wrap my head around at first, but the more I get into like prompt templating and other stuff, it's like you could actually have the same LLM, power all of these, right? The LLM is just like, for lack of a better term, it's kind of like a stateless like being,
right?
And then like based on like what I pass into it, and then like what I get out, then there like I can measure and manage all those other processes. So when we think about, as example, like memory with an LLM, memory is really just like me adding more things to the context to the LLM about what it knows about the user, or some topic as a part of that. So if I'm doing like Q&A, maybe I want to like actually save to memory like some of the questions and then pass those answers in to give the LLM even better context for like I asked it like, why is the sky blue? When it gave me this thing, well, what does this thing? Here's the context, like why I asked that, to make it an even more poignant response for it.
Right, get a more interesting answer out of it. Okay, yeah, there are more than one way. I guess I have to. It does require a bit of a change, a bit of like a turn on how you would normally think about like answering a question. But I guess the more ways you can get context in there, the better.
Yeah, exactly, and then like just coming back, it's like managing context really isn't that different than like things that we already do today. Things that I know about, if I'm a retailer, that I know about Jason, because he uses like a store shopper number, right? Like those are all things where it's like, that's memory that we have, that we could give, a large language model to make a better response as a result of it.
Fair enough.
So
very, very cool. And so I feel like we've learned quite a bit about.
We've gone like here.
We had to tours.
Yeah.
We knew we'd be wandering today. But yeah, I feel like we've learned a decent amount about what happens when I am over token limit.
Yep.
Do we want to dig more into like the context or the caching?
Yeah, let's maybe close out with like a caching example. Because I think it's kind of one of those like like prove it.
Yeah, you mentioned that there's a minimum token requirement in order to get.
Yeah, so let's look here. So I have a few. Let's go in cloud storage.
Of course, my next question is there also a maximum? Like,
there is. So the maximum you can load into cache is essentially the max that of like one of the LLMs that you would support. I don't know. We could load in like a few videos though, and I don't know if we'll do that here. If I can get it a stage, but maybe we load in like 3 million tokens and see what happens.
Yeah,
you're right. I love these bad ideas. It's great. Here, let's.
I do love limit testing, and I love trying to find a reasonable use case to push something to the limit. Like, what is a situation where I would need to have a near maximum cache for an actual use case, where almost the whole request is cached,
Yeah, I think like to riff in like code can get like crazy crazy long on this stuff. And then, the question is really like, how do I like code bases are like, millions of lines of stuff. Like, how do I start to like pare down, like what my actual input is to that?
Yeah.
Like in data, I may do it by domain. So, hey, like, do I understand, like, am I looking at like product domain, right? Okay, well, let's like scope our data model like to, the product components or the product, entities, and then pass that in. There's a number of great things if you read from some of the other coding groups out there where they also use things like function calling to get a graph of they'll look at like and say, hey, pass in a graph of functions, but then like get the code and kind of do retrieval on those different things of it. There's a lot of different ways you can solve the problem, like depending on what you're trying to get out of it.
I wouldn't have thought of trying to explain it like as a source map or a call stack to traverse a code base, but that does make sense. The way my brain went first was, I guess as a former web dev, like uglification and minification of code, making sure that none of my characters, none of my tokens are being used on white space or human readable variables. So just like shortening all of it, it's effectively the same, unless you're trying to read the. If you're going for the functionality, that would work, but if you're going for code-based understanding, that wouldn't. So again, picking.
What's for a lot of languages that I think is like potentially a viable path. One of the hardest programming languages for LLMs to actually like understand has been SQL, and
Fair enough.
generate is SQL, and a lot. If you think of like SQL, like it's not like clean.
No.
What you have is you have a lot of embedded business logic, and you have very little documentation about like what the thing actually is.
And if you ask two competent SQL developers, or even the same SQL developer on 2 different days, they'll solve the same problem in 2 different ways. So,
and they'll use different. They'll be like, hey, like they built a table. Well, embeddings 1 should be used in 95% of the use cases, except when it deals with a very like specific edge condition, in which case you use embeddings 2. And guess what? Like the LLM has no idea because that's not documented anywhere.
No.
So like this is right. Like when we think about, in particular, like the data world, like metadata is hugely important. What does this column of information actually represent?
Mm-hmm.
Because like there are so many things where it's just like it's like undocumented like knowledge that we all have, and like you can't expect something that doesn't have the knowledge to actually be able to do something successfully in it.
Absolutely fair.
It's a process. All right, so we got this in. I got 2 pieces here, so this should put us at like 3 million tokens, right? So let's go ahead and create a cache.
Looking forward to it. Kaio in the crowd is absolutely pumped. Glad to hear it.
This is gonna be good. All right, let's create a cache. All right, cool. I'm gonna take this. We're gonna come back here. Gonna hit the button. All right, so we're gonna do this. We're gonna do our project ID.
Very private. Do not steal.
Yeah, please don't. All right, so let's do this. So we're gonna do. We have a few things here that I'm gonna pull from this. I'm just gonna put them in here while I'm working through these things. So we have our first file URI. And we have our MIME type here, which is MP4. I'm going to put MP4 and MP4. And I created this other one, which is 2. So here you can see we have our system instructions, right? So just for reference, we got system, context, like user question. Yes. So we got to provide that first thing, right? Because that's always the preamble. Think of it as like, hi, I'm Jason. Cool. We always put that at the outset. I'm going to say you are a video analysis producer. Maybe it's the same thing. I'm not entirely sure. I know nothing about that world. Analyze the videos to the best of your ability. It sounds like sometimes I'm talking to my 8-year-old.
We're just playing a game. We just need
Yeah,
to
exactly.
Yeah.
All right, so let's see here. We've got about what, 3 million tokens probably.
Yep, just under.
Let's do it.
All right. And so I'm assuming we're going to get a similar 400. I guess these would pop up in the log explorer under the vertex resource to say in more detail what's happened or why this is being rejected. I've never actually looked at that.
They might. Let's see what we get back.
Yeah.
So here in this case, because we're passing the model name, my guess is that it'll probably look at it and be like, you're over the line.
Yeah, fair.
But yeah, sometimes with these things, depending on the behavior of the model, it's always good to read because sometimes models will actually just truncate versus fail. And that's actually like truncate is kind of dangerous, right? Because like, let's say, I have 1.5 million tokens and it, truncates at 1 million. Well, like, was there something in that 500,000 tokens that got truncated that now I'm like, it's giving the wrong answer?
Right.
This is where I'm like, count tokens, right? Like, very important to always do as much as you can.
Absolutely. I guess if it's a well architected system, it would fail loudly rather than silently and let you know that it's not processing the entire chunk. But it'd be better to ensure that by counting the tokens before sending the request than guessing that's what's happening.
This will take a couple, just because we're going through and like this is a few gigs that we're going to load into the window. But yeah, so here, let's say I wanted to change some of these things, like use Flash. Oh, cool. Here we go. Whoa, look at that.
Okay. Yeah. Just under 3.
It's about the most detailed error message we've gotten so far.
Very precise. So we got a better response for caching than.
Yeah.
Interesting. All right.
And what's nice about this, right? So like actually, so we actually like calculated the input tokens. So keep in mind 2 videos plus the system instructions. And then we can see here, we actually have the allowable count with it. So that's great, right? We could say, okay, what else would we need to do? Like, is there actually like, engineering in terms of reducing our input that goes in? But we have some tangible facts we could go work with at this point, which is cool.
Yeah. Very interesting. That's a perfect invalid argument response like that. I would not have. Well, I guess we could go and look in the log explorer, but that really explains exactly what's happening.
Yeah. So here's the other one. So one of the things also with context caching that we want to be careful of is you actually need a minimum as well. So you want to like caching can be expensive, right? If we're caching just like 6 characters, or 6 tokens, right? Like, why are we reserving memory space for that? Like, so there is a minimum floor also. So let's see if we can find what happens with that one also. So I'm going to come back. We're going to look. I downloaded this document earlier, but I think this is the right one. So we'll find out.
In terms of being just below 32,000 characters?
I think it's like 16,000 tokens.
Oh, fair enough.
And then it is what was that type? It's a PDF type.
And I wonder if we'd be able to cache just the system instructions. Would that actually save us a meaningful amount? I guess over millions of requests it would.
So this is where, like, when we're talking about the like the types and all that, if you look here, like typically what we're caching, right, is like objects that may take like even longer to actually like get some different pieces of. I could also, to your point, like cache like all of the system instruction pieces, but it just would have to be above that token limit.
Yeah.
So sometimes, if you think of like coming back to like our, kind of RAG use case, like I may actually cache like all of the things that came back, and just say, hey, like don't even apply like some sort of like ranker on it.
I honestly, we got a good question in the chat here. Can we explain again why there's minimum? I think that's a great question. It's because it's expensive. It can be you're paying for the request to cache. You're paying for the storage time for as long as the cache remains alive and valid. So you do want it to be over a certain size to justify the request and the cost to store what you're actually caching. But not obvious. Good question.
Invalid deaths.
Oh, we left the GS util line in there. I am thinking in terms of the RAG use case. You could cache like all the readmes for a repository, and then count that as your like baseline for all of your prompts going forward.
Yeah, so there's like there's some wild stuff you can start doing, when you think about these different things. Cool. So here, yeah. So what's great also, like we actually got like a strong failure. So you can see here, to really start using caching, like you got to be in the realm of like 32,000, 33,000 tokens for it. The cache concept I have here is only 14,000 tokens for it. So, I'd probably here in this case, like if I was doing this, this like count what I'm going to need. If I'm going to use it repeatedly, then like load it to cache. Otherwise, just iterate over questions and other stuff for it.
Totally fair.
We've like talked about like, and I'm always curious. One of my things is like, well, what happens if you stuff the window to hit the number? I don't know that that's actually I don't think that's particularly cost effective though. But it is something I'm like, it's a terrible idea. Sometime I want to like see if you can make it happen.
Yeah. I mean, honestly, I feel like I learn more about why I shouldn't do it by coming up to the line of a bad idea. So I'm always interested.
Yeah, you could. That's a lot of text that I'd have to put into my notebook and it'd probably crash.
I am curious about the parameters for caching here. So we are able to configure the TTL. So we have the time delta. It's just a timestamp from now to plus 60 minutes. Fair enough. And
so from the time that you get essentially that like callback, right, that it's successful, you have 60 minutes to use it. We obviously have the name associated with it, and then we could also say, hey, great, with these things, like let's like do the let's like extend the cache, like if a session's still active. But this is where coming back to our favorite table. Let me find it. It's like, which table is our favorite table? Oh, the pricing table, the one that we never want to talk about, right? So keep in mind, like when you're build for this stuff, if you look, a lot of the stuff is actually like when you get it in here. I'm trying to remember which part. There's something in here for it, but you're essentially build for. Here we go. You're built for like the storage costs, like over hours for it. So like that's where as you're thinking about these things, that's like this kind of the hourly notion of it, right? Like really starts to change the thing. Now that said, like if you're gonna like use it repeatedly, right? You can see here. Now that I'm actually using those requests for it, like I'm really reducing like my actual charges.
That makes a lot of sense. It is a bit of a twist to think in terms of character hours, but it is. I'd much rather carefully consider this page and that cost example before building a page, before building my app, and then having it heat up on a hot path and looking at it afterwards to justify my bill. So, this
is where like I think the pricing on it, like the 1.5 pricing is really pretty advantageous, in particular for Flash, like as you're getting started. Because when you factor in some of these different things, like the actual like cost that you're doing per call is like it's like pretty low.
Yeah, just by looking at it here, it seems vanishingly like it seems expensive compared to not accidentally leaving a cache alive, but compared to making more requests at this size. And I see that there's a dual pricing that goes below the 128,000 context window and above. And the price
so like it's essentially like if you pass this like a big thing, it's gonna take more to like do the work on it, versus like a 128 or 128,000 context window on that. Caching here, if you're thinking like agent models, like that sort of stuff, where hey, I'm doing the same, like I'm using the same thing and like over all these different agents for it, like that's where like you also like start to see a lot of like economies, what I kind of call like an economy of scale, but really it's just like a reductive like thing on pricing.
Right.
Because hey, like I don't want to have to give every agent the same context over and over and over and over and over. Like just give you, here's the things, like now do the next step, or like do this next thing as a result of it.
Absolutely, having them build on each other's responses rather than paying repeatedly for the same character usage. Yeah. Very interesting. All right. Is there anything else we wanted to cover here?
I think I'm good.
Yeah.
My cup is probably full with token counts and context caches.
Yeah, I think that there are a whole lot of other topics we could branch into here, but that would be a whole other day, a whole other stream.
Yeah, we'll do it. And for everyone on, first, thanks for joining, Aaron and I. Love the questions and hearing feedback and all the fun stuff with it. If you do have questions, hit one of us up on I don't know if that's X or Twitter. I'm on LinkedIn. You can find me there. Happy to help answer other things that might come up for you.
Absolutely. Likewise, Twitter is great for me. LinkedIn is also great. Yeah, I'm right there with you, Kaio. There is a lot more that we could talk to Jason about here. But I think
I don't know if that's to benefit everyone, but cool. All right. Well, thanks, Aaron, for having me on. Really appreciate it. And thanks all the viewers.
Yeah. Thank you, everybody, for joining us. It has been a great session, and I hope you'll join us next week for our next topic related to 2 million tokens. So, yeah, thank you for joining us, Jason. It's goodbye for now.
All right. Have a great evening. Bye.